Okay, so we're going to try this again. I recorded this a little bit ago and it just didn't work. So hopefully it's going to work. Okay, so I've never made a video about the distance formula, and I just feel like maybe we need that because I've noticed a few people are struggling with that. So here we go. We'll take a look very briefly at the distance formula. And so here we go. So the idea behind the distance formula is we have 2 points. So I'm going to name the first one x1, y1, and the second one x2, y2. And the idea is that we want to go ahead and model this as a simple right triangle. Moving along a diagonal is hard, but moving horizontally and vertically, mathematically, is fairly simple. So if we move from here to here, the only thing that is happening is I'm not moving up and down, I'm moving horizontally. And so what happens is to get from this point to this point, I just need to go over exactly the distance between x2 and x1. And in the same way, the height of this point is y1, this one is y2, so the difference in those heights is y2 and y1. Now, I'm often asked, which one do you call 2 and which one do you call 1? Well, the reality is, as long as you are consistent, when I look at this example in a moment, I could call this one point 1 and this one point 2, or if I reverse them, I'll get exactly the same answer, and I'll try to remember to explain why that's the case in a moment. But see, if we have this story right here, the Pythagorean theorem, I did decide I would write that coordinate down of where those things come together, says if you take side 1 squared plus side 2 squared, you would get the length of the hypotenuse squared, and I'm going to call that d for distance. Now, the only thing I need to do is I need to take the square root of both sides because I don't want the square of the distance, I want the distance itself. So that means we have this thing right here. It's x2 minus x1 squared, second x minus first x, plus second y minus first y squared. And the square root of all that is the distance. And I chose to write d on the left. Now, this is a great formula because we don't need to make a picture. We don't need graph paper. If we have ugly numbers, we just plug it in and go. So the formula here says, let's take the second x, 4, minus the first x, which is -1, plus the second y, which is 1, minus the first y, which is 5. So there we go. 4 minus -1 is 5. 1 minus 5 is -4. Now, I did want to mention something because normally when you do this formula, you will see people put absolute values on these numbers because distances are defined as only positives, and sometimes you'll just subtract and get negative numbers. But we don't usually bother with that absolute value because as soon as you square a number, -4 squared and +4 squared yield the same answer, so it doesn't really matter. So I got a 25 here and a 16 here for a total of 41. So my distance was root 41. Now, on purpose, I left myself some room over here to emphasize something. See, if I have -1 comma 1, 2, 3, 4, 5, it's a good point. 4 comma 1, 1, 2, 3, 4 comma 1. See, this works and it's great, but if I took a moment to do this, I could turn it into a simple right triangle and say that I went down 1, 2, 3, 4. I went over 1, 2, 3, 4, 5. And the Pythagorean theorem would say that 4 squared plus 5 squared is the distance squared, and that leads me right back to root 41. Okay, now that's going to lead me to problem number 12 that you guys were working on in your homework, where they gave us this little triangle. They call it a polygon. They don't name it, but it has 3 vertices. So if it has 3 vertices, it must in fact be a triangle. And they asked me to find the perimeter. Now, they also asked to do the area, and I'm going to do that as well, but let's start with the perimeter. So I could use the distance formula that we have up here, 3 times 1 distance, 2 distances, and 3 distances. But what I've found for me that is easier is I like to go ahead and draw a little triangle in. And so when I came across and up. Notice that I made a nice little right triangle that is 8 here and 5 here. I could say, I'm going to go ahead and label these A, B, C, that the distance from A to B would be 8 squared plus 5 squared would be the distance from A to B squared. That's A squared plus B squared equals C squared. So I got 64 and 25, which of course is 89. So that makes the distance from A to B the square root of 89. I find that easier than this formula that we're seeing right here, but it's a matter of preference. Now, similarly, when I want to find A to C, I'm going to do the same thing, but something kind of cool happened in this problem. That when I go to find the distance from A to C, I have 8 squared plus 5 squared, again, is the distance from 8. Hey, we've already seen that exact same mathematics, so we can see this is also root 89. That actually tells you that these two sides right here are the same. That means this is an isosceles triangle. And then my last little piece is to find the distance from B to C. Now, if I finish this off, this is 3 and that's 3. So I could say 3 squared plus 3 squared was the distance from B to C squared. 9 and 9 make 18. And so that makes the distance from B to C the square root of 18. So keep in mind, I'm not done because it didn't ask me what each side was. It asked me for the perimeter. So my perimeter would be root 89 plus root 89 plus root 18. Or we could say 2 roots of 89 plus root 18, which again, that is not an answer that most people feel super comfy with because it's hard to really know what that really means. And so a lot of times people would choose to do something like this: 2 roots of 89 plus the square root of 18. And I got an answer that's approximately 23.11. That's a little easier to understand. And that's a good way to find my perimeter using the distance formula. Now, I'm going to go, this is the area addition postulate that somehow if I add the 4 triangles together, we would get the area of the big square that I see there. And so that's how I'm going to actually use this data to find this triangle right here in the middle. So there's lots of ways to do this, but I believe the easiest way is to start with the area of the square and then take away the 3 triangles. Take away triangle 1, triangle 2, triangle 3, and then what is going to be left is that shaded piece in the middle. So you want to remember that this big figure right here is an 8 by 8 square, so its area is 64. And then we had 1/2 base times height, which would be the area of this triangle. Then we have 1/2 base times height, which would be the area of this triangle. And then 1/2 base times height, which would be the area of this triangle. So if you picture you started with a square and you cut off that triangle and threw it away, and this one, all you'd have left is that one piece. And so we got 64, half of 40 is 20. Another half of 40 is 20. And then half of 9, 3 times 3 is 9, is 4.5. And putting that all together, I got an area of 19.5 units squared, whatever those are. All right, hopefully that was helpful. And I will see you guys back in class. I'll talk to you later. Bye-bye.